Wildcats. Today we're talking about compound events. The following notes I'm going to highlight and write down what is important. Please make sure if I write it or highlight it that you do the same. First, we're going to talk about the vocabulary word independent. We've used this term in past units, but today independent is going to be when we multiply the probability of the first event by the probability of the second event. Independent is the vocabulary word we're focusing on. Also, it's important to know that we are going to multiply the first event by the probability of the second event. Remember, when we talk about the word probability, we'll also see that represented as a capital P before a parentheses. So, when we're doing this, this is going to be without replacement. This is important when we're talking about pulling marbles out of a bag or cards out of a deck. So, the denominator should be different. Let's check this out. An example, a spinner is spun and a fair six-sided number cube is rolled. We want to find the probability of a vowel and an even letter. So we're going to take a look at this spinner to the right. In the spinner, I have the letters A, B, C, D, E, F. Remember, a vowel is a letter that's A, E, I, O, or U. So looking at that, I see the letter A and I see the letter E. That means that 2 out of 6 of my letters are vowels. I can use the fraction 2/6, but I actually want to simplify it. Simplifying the fraction 2/6, I would get 1/3. Now I want to multiply that by getting an even number on my six-sided cube, an even number. The numbers that are available there are 2, 4, and 6. That leaves me with 3 out of 6 of the sides have an even number. I can simplify 3/6 into the fraction 1/2. These are two independent events, all right? So I'm going to spin and roll the dice. I see that I have a probability of 1/3. I'm going to multiply that by the probability of 1/2. 1/3 times 1/2. I'm going to multiply straight across. You'll see 1 times 1 equals 1, and 3 times 2 equals 6, meaning I have a 1 out of 6 chance of getting this result. If we were to find this as a percent, 1/6 is about 16 and 2/3%, making this a very unlikely event. Let's check out another example. It says, if the spinner above is spun twice, what is the probability of the spinner landing on A and then B? So first, let's find what was important here. We're going to spin it twice. We want to find the probability of it landing on A and then B. I want to make sure what I'm writing is the probability of A and B. Taking a look at this, I'm going to try to show you the results of if I spun it for A and then if I spun it for B. Looking at the spinner, A only appears 1 out of the 6 possible choices, where B also appears only once out of the 6 possible choices. Because these are two separate independent events, I'm going to multiply each of these probabilities. 1/6 times 1/6. That gives me 1 times 1, 1, and 6 times 6 is 36. 1 out of 36, written as a percent, is about 2.8% chance. Again, this is very unlikely that this will occur. Let's take a look at number 2. Number 2 says if a number cube is rolled 3 times, that's really important, 3 times, what is the probability of getting a 1, then a 3, and then a 5? So, the first time we want to roll, then we're going to roll a second time, and then we're going to roll a third time. So, let's set up a probability. What is the probability of rolling a 1, a 3, and a 5? Looking at my number 1, and I'm talking about a number cube, I know 1 only shows up 1 out of 6 of the sides, so I have a 1 out of 6 chance. Looking for the number 3, or my second roll, I have the possibility of 1 out of 6 times as well. And then when I'm trying to roll my third time for the number 5, the number 5 occurs 1 out of 6 times. Each of these being independent events, I'm going to multiply them together. 1 times 1 times 1 equals 1. 6 times 6 is 36. Times 6 gives me 216. I have a 1 out of 216 chance that this is going to happen. If we were going to make this a percent, that means I have a 0.5% chance of this happening. It's almost impossible, but it's still possible, so we'll call it unlikely. Number 3, taking a look at our last independent example. A penny and a dime are tossed. What is the probability that both coins are landing on heads? So they're telling us we have 2 coins. We understand that coins have 2 sides, either heads or tails. We're hoping to find the probability of them both landing on heads. I'm going to come over here and write P for probability, and in parentheses I'm going to write what results I'm looking for. I'm looking for my penny to land on heads and my dime to land on heads as well. So, for my penny, because there's 2 sides of a penny and heads is only one of them, I have a 1 out of 2 chance. For my dime, I also have 2 sides, and again, I have a 1 out of 2 chance. Looking at this to figure out the probability of them both landing on heads, I'm going to multiply. 1 times 1 is 1, and 2 times 2 is 4. I have a 1 out of 4 chance that this will happen. 1/4 written as a percent is 25%, which means it is unlikely. Follow to the next video to learn about dependent events.